Hey, Dr. Clark coming back at you with another differential equations check your understanding video. We're looking at section 2.3, which is on solving linear differential equations. So we've got a linear differential equation right here, first order, linear first order. And in this case, they've given us an initial value problem. So at the end, we will have to solve that initial condition to give us a particular solution, not just the general solution. So step one, let's add this 3y term to the other side to start putting it into sort of our standard form. So I'm going to have what? T dy by dt plus 3y is equal to 5t squared, 5t squared. I'm going to divide by t to get the dy dt alone or by itself. And when I divide by t, I'm going to end up with 5t on the right-hand side. That's an easy mistake to make, not to divide the entire equation by t. And now I have it sort of in the form that we want, which is the y prime term by itself, and then there's this term here, and our integrating factor is going to be e to the antiderivative of that term there, which is 3 over t. And the antiderivative of 3 over t is 3 natural log of the absolute value of t. That would be the most general antiderivative, but the thing is, with integrating factors, you don't need the most general antiderivative, you just need any antiderivative. And so it's oftentimes simpler to omit the absolute value and simply get the simplest antiderivative available, using our rules for exponents and then the fact that the natural logarithm and the exponential function are inverses, the integrating factor reduces simply to t cubed. And that is a simpler integrating factor than the absolute value of t cubed, and this will end up working for us. So then I'm going to multiply everything by the integrating factor, and that will give me the following. What is this? 5t to the fourth. Again, make sure to multiply the entire equation by t cubed. And if we did it correctly, this is always a good spot to stop. This should be basically f and f prime here, and we can see that that is the case. And then this should be g prime and g right here. And this looks like a product rule, right? And that is the idea of the method of integrating factors, is it comes from a product rule, and the integral of the product rule is the product. So when we integrate both sides of this equation, we're just going to get f times g, f being t cubed, and g being y of t. And on the right-hand side, we'll get the antiderivative of 5t to the 4, which is t to the 5th plus c. And that means our general solution will be y of t equals t squared plus c over t cubed. I'm just dividing the right-hand side by t to the 3rd. And you can see that would be our general solution. But this problem asked us for a solution to this initial value problem where y of 2 was equal to 7, and if I plug in 2 for t, I would get, 7 is equal to 4 plus c over 8, so I think if c is equal to, 24? 24 divided by 8 is 3, and 4 plus 3 is 7. So my solution to the initial value problem will be the function y of t is equal to t squared plus 24 over t cubed. And that is the answer you should have for this problem. All right, I hope that was helpful. I hope you got it right. Remember to give yourself some reflection comments and a grade right here to see just how you're understanding the ideas, and use that to further your study. And we'll see you next time.